In this video, I'll use some hands-on examples to explain the concept that machine code is not portable among different processors, while programs written in high-level languages are. Before I demonstrate, let's recap some important concepts regarding high-level and low-level programming languages. First, a computer can only understand and execute machine code that is designed for the particular processor it uses. Second, to execute a program in a high-level language, we must translate the source code into machine code for that particular processor. Third, using a compiler to translate the code generates an executable file consisting of machine code for the target processor. However, modern computer architecture introduces an extra layer where the executable file is expected to be loaded by the target operating system. This means a program compiled on macOS can only be run by macOS. Similarly, programs compiled in Windows can only be run by Windows. We can simply say an executable file can only be executed on its target machine. This is similar to the concept that machine code can only be executed on its target CPU. Now that you understand these concepts, let's look at how high-level code is portable among different machines, while the machine code or the executable file can only be run on a target machine. On this screen, I'm showing two different computers simultaneously. On the left is a Mac computer and on the right is a Windows computer, as shown by their user interfaces. On both computers, I'm using the same integrated development environment, IDE, to write an identical program. It accepts two inputs, A and B, calculates their total, and displays the result. Because high-level code is portable, with the same IDE installed, I can run the same program on these two different systems using the provided runtime environment. Let me demonstrate on macOS. I run the program. When I type in two numbers, it works correctly. On the Windows computer, I'll do the same thing. When I run it and type in two numbers, it works as expected. Now, let me compile the program on macOS. I type and execute a command, and you will see the generated executable file. If I run it, it works as expected. On the other hand, let me do the same thing for the Windows computer. After running the compiler, you will see the generated executable. When I run it, it also works as expected. However, what happens if I copy the Windows executable file and try to rename it as if it were a Mac executable? And what if I do the same thing for the Mac executable? Make a copy and attempt to rename it as a Windows executable. Because these two computers share the same drive, I can go to the Mac folder from the Windows machine, locate the file that was copied from the Mac and renamed, and attempt to run it. It says I can't. You see, the machine code itself is not portable. Let me do the same thing for the Windows version. I'll locate the file copied from Windows and attempt to run it on the Mac. This was originally a Windows executable, but I'm trying to run it on a Mac. It says it cannot be executed because this is code expected to be run on a Windows computer, not a Mac. As you can see from this example, the high-level code is portable between macOS and Windows. You can run the same program on both systems, provided you have the necessary translator or compiler. However, the low-level code, the executable generated from each system, can only be run on that particular system. Low-level code is not compatible among different systems. Thanks for watching. See you next time.